The stuff that us science fiction writers really love.
All right, thank you.
Thank you.
This is for any of the panel members. What's the state of the art of, say, solar thermal propulsion systems, and would that be of any benefit for delivering cargo to Mars as, say, a second generation vehicle? And what about using solar sails? I know you need a humongous sail and it takes long trip times also, but what about those two technologies, solar thermal propulsion and solar sail propulsion?
Solar thermal propulsion sort of got stalled. There was a lot of good proposals to do that in the 1980s, and there was even a Air Force-sponsored program to try and develop it in the 1990s. But it turned out to be sort of hard to find a good mission for it. In many ways, it's a very complicated technology. You have to have very large solar concentrators, and typically the proposals propose large inflatable concentrators, and they have to be pointed pretty accurately at the sun. And then there's a lot of sort of technical details about transferring the solar energy to the hydrogen. Another point is that, like nuclear thermal propulsion, solar thermal propulsion really only works well with hydrogen as the fuel. A nice thing about the ion propulsions, or for that matter even Vasimr, is that you can use much more dense fuels. The ion propulsion typically uses xenon, which is actually a pretty heavy gas. It's, of course, it's liquid when we use it, supercritical liquid. Whereas hydrogen is tough stuff to work with. It has density lower than styrofoam, and you have to keep it very cold. So solar thermal mostly stalled. It might be a good technology for cargo, because like all the electric and non-chemical propulsion systems, the amount of thrust you can get is proportional to how much your energy source is, which means it's proportional to the area of that solar concentrator mirror. So unless you have a huge mirror, you're not getting a whole lot of thrust. Solar sails, on the other hand, were very popular and still are popular with the Planetary Society. They're a very interesting technology. This is a technology that has technically infinite specific impulse. You get no fuel use for your momentum. The downside of that is the thrust is very, 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 very low. It turns out thrust level and specific impulse are opposites. They're canonically conjugate variables. You can't get them high both at once. Solar sails are phenomenally good for very high delta V missions if you want to wait a very long time, years. If you're going to the stars, there's a lot to be said for solar sails. For going to Mars, well, sort of work out the numbers. It's about 6.5 newtons per gigawatt of thrust. A newton, 4.5 newtons is a pound. So a little over a pound of thrust for a gigawatt of power, of solar power. And the solar energy is about 1.3 gigawatts per square kilometer. So square kilometers of sail give you just a little bit of thrust. So it's a great thing if you don't care how long it takes to get there, because you can get there with no propellant use at all, zero. But it takes a long time because it's a low thrust system.
Okay, thank you for your questions. I'd like to thank our panel, Dr. Robert Zubrin, Jeffrey Landis, Richard Heidman, and Rob Terry for their input. And I think it sounds like it depends on the mission. And of course, the mission that we're focused on here is sending humans to Mars. Silver bullet or hoax, let you decide. Thank you. See you again back here at 1 p.m.